In this video we're going to take a look at the Cornell notes-taking method, which is going to be an example of how you can practice summarising your notes. With the Cornell notes method you can see that after we've made notes we can summarise them, but also extract keywords and questions from them. Okay, so the first thing we want to do when making Cornell notes is to write our title. So this one I'm going to do on electrolysis. We then want a fairly wide margin that we can use to write definitions of our keywords. And then at the bottom, some space for our summary of what we have been writing down. So for you to be able to do your electrolysis Cornell notes, you could either use your textbook, which I've got here, or you could use a revision guide or your already existing notes. So the first thing I'm going to do for electrolysis is to actually draw the diagram of what it looks like. So our container with 2 electrodes in it, connected up to a power supply, and then drawing a line to show that it is in an electrolyte. So we can then start labelling. Electrolyte, this is going to be our negative, which is our cathode, and this is our positive, which is going to be our anode. So already we've started throwing some keywords around. So we've got anode, cathode, electrode, electrolyte, and this of course is just the power supply, which is going to make this electrolysis happen. So we can then think about actually how we could break up this word. So we've got an electro part, and this indicates electricity is involved. And then we have this lysis part, and this is telling us that something is splitting up. So with our electrolysis, we are talking about the splitting up of our electrolyte using electricity. Now, our electrolyte is an ionic compound that can either be aqueous or molten. And it needs to be in those conditions in order for our ions to be able to be free to move and therefore complete the circuit. So they must either be aqueous, which is dissolved in water, or molten, where it's been melted to a liquid state, and that allows the ions to be free to move. We could denote our ionic compound as an MX, and we would then have this as M plus and X minus ions, positive metals and negative non-metals in that electrolyte. With aqueous, though, remember, there would also be water involved, and we'll talk about that in a minute. Our cathode, as you can see, is our negative electrode, and our anode, our positive. So because opposites attract, our positive ion is then going to be attracted to our negative electrode, whilst our negative ion is going to be attracted to our positive electrode. And so what then happens is at the electrodes, the ions lose their charge to form elements. So they become their neutral elements in whatever state they would be naturally. So our positive ions, in order to become neutral, are going to have to gain some negative charge and therefore gain electrons. Whereas our negative ions, they need to lose negative charge and therefore lose electrons. When we are talking about gaining electrons, we are talking about reduction, and losing electrons is oxidation. And we can remember that using our acronym LEO, the line goes GER. So gaining electrons is reduction, losing electrons oxidation. And so what we can see from our diagram on this is that our reduction is happening at our cathode and our oxidation is happening at our anode. We can also show these changes using half equations. So half equations show the transfer of electrons, e.g. for our metal ion, gaining an electron to form our metal. We can add in our state symbols, so here in the molten form and metals in their natural state are solid. In aqueous solutions, we've already said we're going to have water present. Our H2O actually splits up into H plus and OH minus when an electrical current is passed through. And so that now means that we have 4 ions in our electrolyte. We have our H plus and our N plus, and we have our OH minus and our X minus. So 4 ions in total in our aqueous electrolyte. So these two, we need to decide which one is going to be going to our cathode, and for these two we need to decide which one is going to be going to our anode in order for those reduction and oxidation reactions to happen. And so there are some rules that we can apply. So for our cathode, we can talk about which is the least reactive, and the reason for that is when we talk about our reactivity series, we're talking about the reverse of this half equation. We're talking about our metal losing electrons to form metal ions when we talk about how reactive our metals are. So our metals which are the most reactive, they're going to lose electrons much more easier, and therefore this process of gaining electrons is actually going to be more difficult. So when we're asking about which is our least reactive, that's therefore going to be gaining electrons much easier. So we can use our reactivity series, but ultimately we are comparing hydrogen versus the metal. And the only metals which are lower in the reactivity series than hydrogen is our copper, our silver, our gold and our platinum. At our anode, the question we want to ask is X minus a halide? So our halides are our group 7 ions, so fluoride, chloride, bromide or iodide. If our answer here is yes, then what we would get formed is the halogen equivalent, so F2, Cl2, Br2 or I2, because this is how our halogens exist as elements. If it's a no, then we end up getting oxygen formed, which is O2. And this is because it is then our hydroxide ion that is going to lose electrons, as well as forming oxygen. It also forms water as a byproduct because of those hydrogen as part of the hydroxide. So a few other key words to add here, and then we can look at some questions. so what a half equation is and what a halide is. So we then want to ask ourselves some questions, which is going to prompt us remembering what we've been talking about there. So the first question I'm going to put down is, what form does the electrolyte need to be in to conduct electricity? And so that's referring to what we talked about at the top, that it's an ionic compound and therefore it needs to be either aqueous or liquid, molten, for our ions to be free to move. The next question we can ask ourselves is, what happens to the water when aqueous solutions are electrolyzed? And that's referring to this part here, that our water also splits up into H plus and NH minus ions. And then our next question is going to be about what are the rules at the cathode and anode for aqueous solutions. And so then we can look at making a summary, so just a few bullet points summarising what we have talked about. So the first one, referring to that definition, electricity is used to split up molten or aqueous ionic compounds into elements. We can then talk about how our reduction occurs at the cathode, whereas our oxidation occurs at the anode. And then for aqueous solutions, there are 4 ions to consider, and only 2 ions will form their elements. The other 2 remain in solution. So what we can now do is we can use another piece of paper to then cover up our main notes and see how much we can remember using those prompt questions. And also we can have a go at filling in our definitions. I haven't left enough space really for the halides, so let's just quickly go through our definitions there. Ideally you would do this whilst covering up, so that you're then testing how much you remember. But for the purposes of my space, I'm not going to cover it up. So our anode was our positive electrode, our cathode our negative electrode. We could also talk about that our anode is where oxidation happens, and that our cathode is where reduction happens. our electrodes are simply conducting rods. They do need to be inert so that they don't react with the electrolyte. Sometimes, however, they do react with the products produced. For example, when graphite, which is carbon electrodes, are used in the extraction of aluminium, it will react with the oxygen that's produced. And then our electrolyte is an ionic compound, which is split using electricity. Then our Leo de Langevin, so losing electrons is oxidation, and gaining electrons is reduction. Half equations show the transfer of electrons, and then our halide is an ion of group 7 elements. And those definitions would be useful on flashcards as well. So you go to the video on flashcards to learn more about how to use those effectively. And so with Cornell Notes, a really great way to use these is to cover up the note side and test yourself and see how much of that you can remember using those keywords and questions as prompts.